Hey, what's up guys? Welcome to Philip's Treehouse. Can you say hi?
Hi.
Hey guys, so we're trying to figure something out today. We want to know how fast his zip line is. How are we going to figure this out?
So we're gonna put light and heavy objects on there and figure out which one's faster.
And what do you, yeah, so what do you think is going to be faster?
I think heavy is going to be faster because we're going down.
Yeah.
And we're and it's not on the ground.
Yeah. We should write this down. What were you saying?
Because it's not on the ground, and usually when stuff isn't on the ground, heavy goes faster because the gravity is pushing it down more.
Perfect, because heavier objects they have the more force of gravity pulling on them. Don't you think?
Yeah.
Okay. Because heavier objects or heavier stuff, right?
Mm-hmm.
Because heavier stuff should fall faster, right? Let's find out if that's the case. All right, let's try.
That's a long sentence. If we use heavier objects, then the zipline is faster because heavier objects usually goes faster when it's on the ground or not on the ground.
All right, I think we can test that. Do you think we can test that?
Yes.
Do you think we can measure this? Let's do it. So we did some thinking about how we want to test our zip line, and we came up with three different objects, three different examples of matter to test our zip line. So our first object is this cool 30-pound kettlebell, and we verified its weight. That indeed, it is 30 imperial units of matter, of mass, 30 pounds, 30.0 pounds. We also tried this little guy, or excuse me, Thanos, this big guy, and put him on the scale, and he actually was too light to register any weight, less than a pound. It's okay, Thanos, I'm sure you're still inevitable. But of course, Philip, what's our third object gonna be?
Me, and I am 62.2 pounds.
All right, so those are our three masses that we're gonna use for our zip line. You ready to go, buddy? All right, let's test it out on the zip line. Go. Trial one. Ready for trial two? Here we go. Go. Ready for trial three? Go. Whenever you're ready, bud. Finally, a proper trial for Thanos. We ready for the Thanos trial?
Yes.
Here we go, trial one. Trial two, you ready? Thanos trial two, go. Trial three.
Here we go.
Go. All right, time for the trials with our third object here. And just a heads up to everybody at home, Philip has done this for many years, so he knows how to use this zip line safely. And we're gonna be extra careful because we are always safe in science. We're gonna wear a helmet. Safety first, right?
Yep.
All right, here we go. You ready, buddy?
Yep.
Okay, let's do it. All right, trial one with our 62.2 pound object. Ready, buddy?
Yes, start.
Go for it. Nice. Trial two, ready?
Yes, start.
Go. 60-pound trial, trial 3, ready to go? Go! So what was your average time, 60-pound boy?
So my average time was 3.36 seconds.
Right, so your average time was actually a little bit slower than the other two average times. But Thanos, our lightest object, was not faster than the 30-pound weight. So what do you think that means? Did the weight actually totally affect the speed of the zip line? What do you think? Probably not, right? So we might have to address some other factors here.
Yeah, it like shaked when it touched.
Exactly. So there were some other things going on, weren't there?
Yeah.
Let's figure this out. Okay, so we've got our conclusion. We've got a lot of information. We figured out that our fastest object was not the 62-pound human. It wasn't Thanos either. It was our 30-pound weight. So that tells us that since the 30-pound weight in our analysis, the 30-pound weight was what?
Was fastest.
Fastest, but
not by much.
so it was fastest, but only by just a little bit, right?
Yeah.
So that tells us our results were different than what we expected, and that weight did not necessarily mean the fastest on the zip line. Remember when we dropped objects from the treehouse? Different objects, you, Mommy, and Lizzie? Remember that? Well, there's a video of it I'm going to show you. You three throwing or dropping different objects from the treehouse at different at different weights, and they all fell at the same speed and hit the ground at the same time. Remember that? And that's going to help us further understand the results of today's experiment. So I think we just demonstrated the role of gravity and the role of the mass in how it affects speed, and sometimes how it doesn't affect speed. So thanks for your help today, buddy.
Thanks for watching my experiment.